Welcome to our session today. My name's Alan Behrens. We're going to be talking about unlocking the next generation of 3D software, which is getting started with Parasolid's insights from Siemens Digital Industries software and AMC Bridge. I'd like to thank you for attending. Welcome. Today I have two participants. First on the, I don't know which order it appears on your screen, but we've got Evan Knatila from Siemens, who's going to introduce himself in a couple of minutes, and we have Kirilo Nazarov from AMC Bridge. So hello, gentlemen, and let's crack straight on. My name, as I mentioned before, is Alan Behrens. I'm an industry analyst. I specialize on software for manufacturing industries, and I do thought leadership and consulting, a lot of it to the vendors as well as end users, really about the use of software and new technologies, new materials into the manufacturing sector. You know, how they can be used, and who should develop what, and also speaking to the vendors, such as we've got here, on helping them to develop the right solutions and to address the right pain points. So just before we start, we have a couple of logistics topics. The first thing is that we're obviously online, we're being recorded, so I hope you don't mind. If you do mind, please drop off now. We have two speakers. They're now going to introduce themselves. I'll introduce you to Evan Knatila from Siemens Digital Industry Software. Evan, why don't you just explain who you are, what you do?
Sure. Yeah. Hello, everyone. My name is Evan Knutula. I'm the Vice President of Global Sales for our PLM Components product line at Siemens. So I run a global sales team that is responsible for licensing a lot of our core IP, such as Parasolid, and actually a pretty broad product line, to third parties globally. And I've been doing this for about 25 years. That's why there's you'll see some gray on the head up here.
And we have from AMC Bridge, Kirilo Nazarov. Kirilo, just explain who you are and what you do and what your organization does.
Of course. Hi, everyone. My name is Kirilo Nazarov, and I'm a delivery manager at AMC Bridge. So just as a quick intro, AMC Bridge is a software development consultancy with a focus on everything related to engineering, manufacturing, and construction industries. So that includes CAD, CAM, simulation, PLM, robotics, and really anything else that might be in some way related to these areas. Personally, I've joined AMC Bridge 12 years ago as a software developer and got my hands on Parasolid in my first year here, and never really stopped working with it since. Though I've also worked with a fair share of other geometry libraries as well, so you could say that working with anything related to geometry eventually became my specialty. And today I'm here to tell you how we've implemented a variety of successful projects based on Parasolid and why it might be the right tool for you as well.
Great, thank you very much, Kirilo. There is one more logistics topic which I'd just like to mention. There is a question options on the right-hand side, top right-hand side of your screen, little question mark in a box. If you have any questions during our conversation, please put them in there. We'll try and address them at the end of the session, and obviously any that we can't address on the day or today, we'll address further down the line. So let's just talk about our roadmap for what we're going to discuss today. We've got three main areas. The first is how Parasolid's modeling APIs, thousands of them, actually help you to deliver high precision, scalable 3D applications. The second topic we're going to talk about is strategies for accelerating your development and reducing your complexity using these PLM components. And the third one is some real world success stories that AMC Bridge is going to share with us about people, or not actually people, but general case studies of the types of work they're involved with, not being specific to any particular client, and the success and some of the key points that are useful to share with people that are starting on this venture. So let's start off with a little quiz just to set our expectations of the sort of the levels that we'd like to explain things to you. And we would like to know what your experiences with Parasolids. Are you totally new and exploring it? Are you in early integration stages, proof of concept, and actively using in production? And we can see, obviously, people are entering the data. Evan, predictions, what do you think?
Well, I did see a number of our customers registered for the webinar, but I would guess the majority is going to be completely new or exploring.
Yeah. And that's certainly what we're seeing here online. I don't know if, I'm sure you can all see it as people are entering in there. Very interesting, actually. So this is an interesting area for us to bear in mind, that we need to be cognizant that people may not know the Siemens verbiage and some of the acronyms that we might use. But let's move on and talk about Parasolids and why it matters. So Evan, Parasolids is introduced as a market-leading geometric modeling kernel. But from your perspective, what makes Parasolid so foundational across the industries to which it applies?
Yeah, Alan. Well, I think now if you kind of look at it, if you look at the digital thread in manufacturing, Parasolid is really at the core of this. Whether you're talking about doing conceptual design, you have cool products like a Shaper 3D or a Siemens LX, or you move into detailed design of whatever you want to manufacture. NX is going to be there, SolidWorks, Onshape, some of these projects all based on Parasolid. Move into analysis, analysis up front, right? Increasingly, whether you're using Siemens SimCenter or ANSYS, SimScale, they're all based on Parasolid. Moving into the manufacturing side, most any CAM product you're going to name is going to be based on Parasolid and using Parasolid. So you've got one common geometry format. So it's basically translation free across the digital thread, I think, which is great for end user customers, right? You don't have to deal with translation of formats, a lot less than you used to, perhaps. Parasolid really now, and people think of it, originally a BREP modeler. I mean, what Parasolid now is very much a mixed modeler. So, in 2016, we introduced convergent modeling, which was a major implementation of bringing in mesh data into the Parasolid model. Now we're supporting implicit modeling, and we support cellular modeling, non-manifold modeling, all these different types of modeling you can do in one system, and it all works together in one model. You can have mixed data types. You can do all the operations between them. So I think that's really important. You can deploy Parasolid is deployed on cloud or desktop. I mean, if you look at Shaper 3D, for example, it's even on the Vision Pro, the Apple Vision Pro, right? So we've got the platforms covered the developers care about. Parasolid supports Python now. So increasingly being used for AI applications. I think it's foundational too, because, Siemens, we've licensed on this level playing field policy for the whole history of Parasolid, meaning we license to the entire industry, and, we don't take advantage of that. New releases of Parasolid go to our third-party licensees. At the same time, it goes internally to, of course, all our products at Siemens are built on Parasolid. And that kind of goes without saying. So I think that's some of the reason why Parasolid is very foundational in the industry today.
And from what I understand, because it is a sort of foundational technology, and the way that you've actually developed it and licensed it, it's also deemed as being somewhat of a standard, isn't it?
Yeah, I mean, it's, I think you hear people saying it's a de facto standard, and certainly I would say that's true. We have many customers who license Parasolid even just for interoperability. So nearly any application, you know, whether on the cloud or on the desktop these days, is going to at least be able to interoperate with Parasolid data. With, you know, most products, actually many products, we've got over 200 customers being built directly on Parasolid for their modeling capability.
Right, excellent. So obviously it's used widely across industries and through the product life cycle. So let's discuss that a bit further, Evan.
Yeah, so, you know, one thing about a Parasolid, you know, we're not just working with, you know, large established companies. We're working with as many of the startups out there that we can. You know, so it's a big emphasis for us, is trying to get Parasolid into the startups, because a lot of startups, they begin with open source, you know, and they quickly realize the disadvantage of that, you know, as they start to try and maybe put it into production. So I think that's really important. Starting with Parasolid, we have experience working with startups out there. We were able to structure deals that work. You know, we're all about win-win deals with our customers. What's also called as a shared success model. So I think that's important as well. We're not just in the core manufacturing as well. I would mention there's many areas where Parasolid is being used. A major one is going to be architectural, engineering, construction. So when we have major customers, you know, such as Nemetschek and Bentley and others, that are using Parasolid. So Parasolid is also used for modeling not just mechanical things, but structural as well. For example, you know, plant design and that kind of thing. Even within the EDA space, you know, Cadence and Synopsys are using Parasolid. Yeah, I guess it's foundational across many different industries. I'm not sure if that fully answered your question, Alan.
Sorry, Alan, you're muted.
Want to just add to that, Kirilo?
Sorry, could you repeat that? You were muted for half a minute.
Oh, sorry. Would you like to add to that comment?
Yeah, sure. So I would like to echo Evan's point that Parasolid is used in many fields, and add a bit from our experience at the MC Bridge. So we often see companies that work with geometric data in one way or another, and their business may not even be centered around CAD at all. So you could think of Parasolid as a CAD kernel, but in reality, it's a much wider than that. It's a geometry kernel, and those businesses may be focused more on simulation or manufacturing or visualization or something else entirely. So Parasolid is suitable for those cases as well, because what they really share is the need to process geometric data quickly and reliably. And well, Parasolid does exactly that, no matter what your business area is.
Good, thank you. And it's not just where it's used; it's how it supports a life cycle, isn't it? It's about going from concept to, for instance, in AEC, from you know, design through building through operation, in manufacturing from concept through production, manufacturing, and support. So it's also used across different systems and different domains, as we've already mentioned, AEC and manufacturing. But how do teams maintain consistency, Kirilo?
Yeah, so we all know that full life cycle of a product almost always includes many steps that involve many different layers of software that is being developed by different teams. So from concept to simulation to manufacturing, there is a lot going on. And when all these layers treat your data in different ways and output different things, consistency becomes a huge problem, right? And there are not actually many tools that can address it. And Parasolid has an edge in this area because it is entirely viable to use its data as what we call a source of truth, which you tap to quickly produce inputs for any downstream application and process whatever that downstream application gives back to you. This means that you have a comprehensive toolkit to prepare your data for any operation and fix any interrupt issues that may arise in boundaries between software. And we'll explore some examples of that in a bit.
Okay, thanks. But Evan, what does this level of adoption really mean for companies evaluating Parasolid in particular?
Well, I think it means you can be assured you're using a proven product that's been proven over a long period of time. So, from a quality standpoint, from a robustness standpoint, I mean, one thing I'll say, because of where Parasolid is, what products it's in, including, all the way into the very high-end CAD such as NX, SolidWorks, we have seen and solved more edge cases. Edge cases are very important in 3D modeling, right? Because there's so many. It's a general product, right? You can design pretty much anything in it. So there's many edge cases, millions of edge cases, really, that we have hit over time, and we've seen and solved these. These are all math problems. At its core, Parasolid is a very powerful maths kernel. We have enhanced the product based on what's actually been manufactured, and a massive amount of the world's products are built using Parasolid and manufactured using Parasolid. So I think that's a real advantage, is the right reliability, the robustness, and we've really worked on, ease of use with Parasolid as well, which we'll talk about in a minute.
Great, thank you. And I think let's not forget, and I'm perhaps talking out of line, but Siemens is a global behemoth, as they call them in the industry, and you have the wherewithal to support the development of softwares where other companies may struggle, especially for something as sophisticated as a kernel. So I think let's not underestimate Siemens's position as a large, significant software company to support the developments on Parasolid. But it isn't just technically strong; it's proven, as you said. It's everywhere. It supports every stage of the development journey, product development journey. But that sets us up perfectly to talk about the business side and being practical about this, Evan. Why would a company bet their development efforts and their business on Parasolid?
Well, if you need modeling, you need modeling. And if you're going to try and create it from scratch, I would say that's a pretty daunting thing to do. I mean, going back to your comment earlier, we've had, well over 100 people for decades investing in this particular technology. Most of them are based in Cambridge, UK. They're top mathematicians. We have many PhDs on that team, and masters mathematicians. So that's hard to duplicate, right? First of all, most companies are not going to make that kind of investment in just to get a modeling kernel. So I would say leverage is the number one thing here. With Parasolid, you're getting tremendous leverage. You're leveraging 35 years of history. And with that, you can accelerate your time to market and time to revenue and have a focus on the things that you're an expert at, whether it's the simulation codes or it's, CAM manufacturing or whatever it is. You let Parasolid do the heavy lifting on the modeling, and you can build on top of it your value add, so that you'll get a tremendous acceleration in time to market and time to revenue versus using maybe open source or trying to develop it on your own. Parasolid also it's very plug and play. I didn't mention that earlier, but if you implement Parasolid, you're able to read files that may have been created, a couple decades ago. We'll still read into Parasolid, right? XT files, which is the format that Parasolid uses. Also, we don't break your API, and that's really important. So if you have code and you're delaying moving to a new version of Parasolid, and then you move to a new version, your old code's going to work. We make sure that we're forward and backward compatible from a data standpoint and from a API standpoint. So that's, you get the scalability with Parasolid and the acceleration of the time to market, time to revenue.
Great, thank you for that. And I suppose shifting to you, Kirillo, we've covered the business and technology side, but what about the implementation side? What convinces teams to choose Parasolid from your point of view?
Right. So what I think is impressive about Parasolid is how it continues to evolve after all these years, introducing not only bug fixes and improvements, but also entirely new features that are often needed in the real world. And two examples that come to mind, Evan also mentioned those, are convergent modeling, which introduced meshes as a first-class citizen in Parasolid, and implicit modeling, which give us a way to represent an object's inner volume in a non-uniform way. And even though these features may be considered foreign to a BREP modeler, lattices are extremely important in additive manufacturing, and meshes are still used pretty much universally, especially when you step outside the CAD world into simulation, visualization, and other areas which still use polygonal data. And all this means that Parasolid still fits easily in modern systems to address modern needs.
So this really is a symbiotic relationship between the two of you, and a partnership which delivers a sort of joint benefits to customers.
Yeah.
Talking about, yeah, thank you. So talking about improvements, just a second quiz, if I may, to you, the audience. What are the areas you're most interested in improving with Parasolids? And obviously we had a 60% or so new usage and evaluation. Let's have a look at what the audience says. Kirillo, any thoughts on bias? Any guesses?
Well, I think interop would be quite important, again, because many people are building connected systems and they need their data to talk in different parts to each other. So I think that would be quite important.
Okay. And certainly, although we haven't had a huge amount of responses, certainly, amongst the top, there's a reasonably even spread between interoperability, modeling, simulation, and data analysis. But you can see interoperability increasing. So thank you very much for answering that, everybody. If we can just move on, I suppose, one of the questions which people are very interested in is, especially the audience from new users, is how easy is it to get started, Evan? I mean, what does it take, and where does one start?
Oh, well, Parasolid, of course, it's a complex piece of software. It has over 1,000 APIs, and extremely powerful. I mean, the functionality is very comprehensive, right? So our focus has been trying to help customers get started as easy as possible. I mean, along those lines, some things we provide is our Jumpstart kit. So when you install Parasolid, you get a nice HTML interface that's all indexed and allows you to very quickly navigate all our documentation, our sample code, in a very logical way. Our our documentation is, top notch. I mean, Parasolid is thoroughly documented. The APIs with many examples, lots of sample code. We also, in terms of the environments, we support the development environments. I mentioned Python scripting earlier. That's very important. You can use C#, C++ environments to develop with Parasolid. We do provide extensive example code, but I think probably one of the more important things we provide is a prototyping environment. So if you want to get started quickly with Parasolid, you can bring up a piece of software we've developed called workshop.net. It allows you to prototype different bits of code with Parasolid, prototype some of the add-ons, work with some of the add-ons, such as we have a healing and repair technology called Body Shop, this licensable, and then translators such as our step translator. You can work with those quickly in the prototyping environment. The graphics are already built there, and then also use the sample code as well. I think next I've got to mention our support. So we have a large developer level support team based in Cambridge that loves what they do. They are world class. They work closely with our customers. Along with Parasolid, you get unlimited telephone and email support, plus a system that you can report any problems and things like that. That team also does things like if you're going to evaluate Parasolid, for example, they're going to do a phone call with you to understand your requirements and make sure your evaluation gets a good start. We also do provide in-person training, or we can do a training over the web as well. Then beyond that, I'm going to mention AMC Bridge, of course. So AMC Bridge, we've been working with for several decades now, very closely. They are our strategic partner for development services and consulting services for Parasolid. Their staff is expert, not just in Parasolid, actually on our entire product line. So if you're implementing D-Cubed for constraint management, or Kineo, or even you've licensed our Solid Edge product as an OEM, which is something we also offer, or our JT Open toolkit. They can help you with all of that. So I think that's very important. So if you need extra development resources, you need expert consulting, they're going to be able to provide that for you on Parasolid in a very expert way.
Which is a good segue onto the question I've got for Kirilo, which is, how do you step in and help with the accelerated integration with new clients?
Right. Well, first of all, we provide a full spectrum of consulting services. So we can start from a completely new idea of a project, or from an existing product, and create an improvement or integration with Parasolid for an existing product as well, or even migration from another kernel to Parasolid. And if it's a completely new project, then we start from gathering the requirements, converting them to user stories, creating this detailed development plan, and we involve not just software development resources, but QA, UI UX design, DevOps, and so on. And well, as Evan mentioned, we have a lot of experience with Siemens' technologies. So let's say all PLM components across the board. So that includes Parasolid, D-Cubed, Kineo, and also CAD systems like Solid Edge or NX. And what is also important to mention, that we have experience not just with Siemens' components. We work with other technologies as well, and that gives us understanding of, well, if you need your data to come from other systems or go to other systems, how they will interoperate, how it works on the other side of the fence.
Great, thank you. And I suppose that brings us neatly into talking about some real world case stories, and you've prepared a few for us, haven't you? The first one being in AEC, am I right?
Yes, that's right. So my first example is a very ambitious project in the AEC field. So it is, to put it simply, an interconnected web of applications and add-ins meant to streamline interop in the AEC field. So it's oriented towards building data first and foremost. And by building data, I mean a wide variety of data. It may be rough concepts from SketchUp, or detailed models from Revit, or visualizations from a rendering tool, or even a simple spreadsheet from Excel or Google Sheets. And these applications and add-ins that we developed push and pull this data, and backend services make sure that it stays up to date whenever and wherever it's needed. And one of these services is a geometry worker, which leverages Parasolid under its hood alongside dcubed, the constraint solver library, and also hoops exchange for CAD file I/O. And while it supports many modeling operations on its own, much of its value is in supporting interoperability. For example, one system may be working with meshes, so you need to quickly tessellate your BRAP data from the other system. Or maybe you need to generate new geometry entirely from scratch based on some constraints from somewhere else. So to give some examples, imagine a case where you decide that floor height is not quite right in your building, so you update a number in an Excel spreadsheet, and then Parasolid regenerates the 3D model with new floor heights and all objects on those floors updated accordingly. Or another case where you're modeling a building and you'd like a complex free-form roof modeled in something like Rhino and Grasshopper, which are more suited towards modeling kind of these free-form surfaces. So you do just that, and then our system takes that geometry and replaces the original roof in the building model. So these are the types of seamless exchanges Parasolid enables, speeding up iteration while preserving consistency.
Interesting. And obviously, you know, cloud-based or platform-based, are there any significant thoughts that people need in the to maintain in mind or top of mind regarding how they develop for one platform or the other?
Well, for sure, I would say developing for cloud and developing for desktop are two very different things. Although I can say that Parasolid is suitable for use in the cloud because it is thread safe. It can support multiple tenants. It can support multiple users doing different things within the same session. And there are a lot of things you might consider working in a cloud environment. So whether you are working stateless or stateful, do you keep the session? Do you keep all these other things, which also translate into how you work with Parasolid. So there are definitely things to consider here.
Interesting. And what about an example in the world of mechanical engineering?
Yeah, so next, I will be talking not about one particular project, but several different projects and clients that share the same business area, and namely sheet metal. Somehow Parasolid became quite popular among sheet metal related projects, at least at MCBridge, and I'd like to highlight what we did in this area as a collective whole, because it demonstrates quite well how Parasolid fits across many different manufacturing phases. So to start with an early phase, when you look at the end-to-end process, there are multiple points where you need reliable geometry processing. And first of all, request for quote. So you receive a design and you need to tell the customer how much it will cost to manufacture. And here analyzing the geometry helps because you can do feature recognition, you can calculate the dimensions, and then map that data to manufacturing processes and relevant costs. This step is quite tricky in practice, since often draft designs might have issues and be just plainly non-manufacturable as is in the real world, but you still want at least some kind of rough estimation. So you have to play fast and loose with some rules, and luckily Parasolid can do exactly that. It can work with non-manifold bodies, and it also supports variable tolerance where it matters, especially when you're working with data from other CAD systems or other modeling systems in general. And the next step is simulating and planning the manufacturing process. Now here you can't play fast and loose, and you need precise data to make sure the machine does exactly what you want. So you need to check whether the design is actually manufacturable. And if not, well, why? And this goes beyond just checking for manifoldness or self-intersections, these pure geometric checks, because physical machines have constraints of their own, and you need to map those to specific rules in code. This is also something that we achieved by leveraging Parasolid. And interestingly, this and previous steps do not involve any geometry creation or editing, just analyzing what you already have. So while Parasolid is known and has extensive modeling capabilities, its analysis functionality doesn't disappoint either.
Interesting. Evan, there was Kirilla mentioned it earlier about migration of kernels, and the fact that there's experience on that. Have you got any words of wisdom of companies that might be interested in moving from one kernel to Parasolid?
Alan, I apologize. My audio cut out. Was that question
Okay,
right?
so it's not a problem at all. The question is really about a comment Kirilla mentioned earlier about moving kernels from kernel A to Parasolid. What have you got any words of wisdom to the audience, just advising them on the practicalities and the concepts?
Well, it's certainly been done many times in the past, and something we have experience at helping our customers do. It's best to start with Parasolid from the beginning, I would say, so you don't have to go through that conversion. But it is pretty common, especially with open source, because many, like I mentioned earlier, I think in our conversation, a lot of startups, they want a prototype and they start using open source, right away, and then they realize, they need to convert. So we've got a lot of experience converting from open source kernels to Parasolid, as well as commercial kernels. So, I mean, you look at our own Solid Edge, for example. Solid Edge used to be based on another kernel, and it was migrated to Parasolid. And just to give you some data from that, my understanding, it took 2 or 3 engineers about a year to get to beta on that project in terms of the migration. So it is, it's a lot of work. It's significant work, but we do have a lot of experience, and there is, we understand how to map APIs from one kernel to another, so we can help provide guidance on that. And AMC Bridge has experience with that as well.
Great, thank you. Kirilla, we've got time for one more case, if you can share that with us.
Sure. So the last use case I'll talk about today is a low-code generative design platform. And well, you may have seen low-code before. It's a system where you create a workflow by chaining multiple nodes or maybe other UI elements that perform various operations. So essentially, you're building a workflow from these small building blocks. In this case, there are a lot of geometric operations in this platform, and they're powered by Parasolid. And it faces a special kind of challenge here because you have to regenerate the entire model at the slightest parameter nudge anywhere in the workflow. So you have your entire workflow, you change some parameter, and it runs through all these operations and creates the new model for you. And it must happen quickly because speed really matters here in this kind of rapid prototyping environment. And this was achieved through the fact that Parasolid has excellent performance and stability just by itself, but some smart optimizations also help squeeze the most out of it. And here the tech stack also included Hoops Exchange for CAD-file I/O and Hoops Visualize for rendering the output. And there were also some other libraries as well, for example, for simulation. And an important part of implementation was making sure that data flows to and from Parasolid and interoperates with other components effortlessly. And as a result, our team helped in creating this application, which allows for quick iteration, which results in robust, manufacturable, and optimal designs, backed up by simulation results as well, all in one seamless workflow.
Great. So I've got a question for you, which is, I understand that a lot of companies are currently interested in AI, and there are some starting to use Parasolids to deploy AI design to manufacturing workflows. Are you getting quite a few questions along those lines at the moment?
Yeah, well, we get a lot of questions about AI. No two ways about that, because it's the most important technology in the field today. And there are some ways and some clients who are looking at Parasolid and thinking if they can use AI to support their geometric operations, to work with their CAD data. And it is entirely possible. Although Parasolid does not have any AI capabilities by itself, it can be used, again, for interoperability to read the data and also calculate some parameters from the data. You can calculate the dimensions, you can calculate things that you would feed to your AI model to train it, like different angles, different lengths, depending on what kind of operations you would like your AI model to support.
Great, thank you. And I suppose, I know this is a tad of a piece of string, a length of a piece of string, but how long and does a typical integration take, or integration project take from your side?
Well, I'd say that there is no one-size-fits-all answer to this question, since you can do so many different things with Parasolid, as we discussed already. And sometimes you need a small geometry processing service. Sometimes you actually need your own modeling system. But what I can say is that Parasolid comes with everything you need to prototype quickly. As Evan also mentioned, it has the Jumpstart kit, has excellent documentation, excellent support. So often, even with complex projects, we can get a working prototype out in a month and then MVP in 3. Of course, it all depends. But if it's a simpler project, then sometimes we can also whip up a proof of concept in a week or so. It also, again, depends on whether you're starting an entirely new project or moving from another kernel or adding new functionality to an existing product.
Great, thank you. So we're now moving on to the Q&A stage. So feel free to put any questions in the sidebar. We have quite a few here, a number from John Callan. How does Parasolid accommodate PMI data? Is it purely a geometry modeler, or is it a complete product data modeler? Who wants to take that, gentlemen?
Yeah, I mean, I can answer that. No, PMI is a higher level construct above the kernel level. I mean, certainly Parasolid has an extensive attributing system, that can be used. It's very general, but yeah, typically PMI is implemented above Parasolid. For example, in our JT format, we haven't mentioned JT, very important format for the manufacturing industry, which does support PMI extensively and embeds Parasolid as its a BREP or geometry format.
Great. I'm going to just rattle through these. Ian Braid mentioned that solid modelers required too much precise data too early in the design process. How does Parasolid address this to be able to provide an environment which supports conceptual modeling? Kirilla?
Yeah, I can comment on this. As I mentioned in the example with sheet metal, we are working with non-precise data. Again, it is entirely possible to get not a solid model at all in the first place. It might be a sheet body or something else, just because the tolerance of the original system is not the same as with Parasolid. And well, again, Parasolid supports non-manifold bodies and variable tolerance. Also, what really helps is the body shop component, which is aimed at healing geometrical and topological imperfections in the model. And sometimes even if it's a sheet body, you can run it through body shop and make it a proper solid body that is easier to work with.
Right. We've got a question here from Michael Katz, who says, I worked for AMD, and a few years ago our team created some sample applications to showcase how common geometry manipulations could be scaled to take better advantage of multi-core CPUs. This type of performance tuning is even more important in a world where CPUs have heterogeneous core architectures. Is the Parasolid team open to engaging with AMD to explore ways to optimize the performance of Parasolid on modern x86 CPUs? Probably one for you, Evan.
Yeah, Michael, I would say if you could shoot me an email after this conference, my contact information is going to be, I believe, at the end. And yeah, I'd be happy to talk to you about that. I know some folks from AMD are, I believe, registered and attending our innovation conference coming up in Cambridge, UK at the end of April. I think that's maybe a segue into into the slide you were going to put up on that. So yeah, we'd love to see any of you at this conference. It's our 4th innovation conference. It's a very exciting 2-day conference. It is free of charge except for your travel, and you'll get to hear a lot more about Parasolid as well as our other components, including where we're going for Parasolid. A chance to talk to our development leaders, for example, and hear from many of our customers. We've got a huge lineup of customers talking about their use of our components, many of them, of course, implementing Parasolid. Companies like, Onshape, all the way to startups like InCube in the UK, or Toolpath Labs is another really exciting startup here in the US, and a whole bunch more. So yeah, I would encourage you to register for the conference. It's the 28th and 29th of April. AMC Bridge will be there, of course, as well as some of our other partners. And Alan will be there as well, so you can talk to Alan in person.
John Callan, apologies, I'm just going to skip to some others who haven't had questions answered yet. From Jürgen, is Parasolid from the browser always used via client-server architecture with the modeler running on the server, or is there a way to run it directly in the browser? Which one of you gentlemen would like to answer that?
Well, this may be getting at WebAssembly support running in the browser. So that is something I will say we are working on. So yeah, you're going to see that. Dcubed already supports it. Parasolid can be implemented on the server or on the desktop. Obviously, look at a product like Onshape. Parasolid is performing very well on the cloud, on the server. We have many desktop implementations. Specifically in the browser, I think you're really talking about WebAssembly there. So stay tuned on that. We'll probably be talking more about that at our conference as well.
Yeah, it's a good reason to go to the conference if you want to find out more. So one here from Vishwas: how can the Parasolid kernel be leveraged with a generative engineering platform to ensure robust topology generation and maintain geometric integrity during iterative design optimization? Kirilo, is this one for you?
Well, this, I believe, is quite a broad question, because there are a lot of things you could do with Parasolid. And I think, well, the first thing that helps here is that Parasolid maintains precise tolerance within its own models. And when you are performing operations like you're changing topology for generative modeling, it keeps this model tight, and you can do different kinds of operations with it. And also now it supports implicit modeling as well. But in reality, there are a lot of facets to this question, I believe.
Again, you know, if you're able to come to the conference, you'll have more time to talk to the actual developers about this. We've got one here from Reinhold regarding cloud-based AEC collaboration platform. So this seems to be a BIM solution like Autodesk's ACC. Surely Parasolid can be used, but which file formats can further be uploaded?
Well, here I can answer that. Once again, I mentioned that we use Hoops Exchange for that project, and this is a separate toolkit for interoperability, which supports very many different CAD formats, and it supports also some AEC formats like IFC, like Revit, I believe. So it can import dozens and dozens of different files just through Hoops Exchange. And it also has excellent connection with Parasolid, where through Hoops you can get Parasolid bodies, Parasolid assemblies just in one operation. So it's a very straightforward integration between them.
I'm glad this came up. If I could interject, Alan, if that's okay.
Sure.
So yeah, TechSoft 3D is a strategic partner as well, decades-long close partnership with TechSoft 3D. In fact, we resell Hoops Exchange and Hoops Visualize. TechSoft 3D resells Parasolid. They'll be at our conference as well. But the integration between both Hoops Exchange and Hoops Visualize with Parasolid is very tight. When you license Hoops Exchange from us or from TechSoft 3D, you get that integration included. So you can access over 30 formats, including many of the AEC formats, to get data. You know, it's a data access system that allows you to bring the data into Parasolid, and anything that's above the geometry level still comes into Hoops Exchange and can be accessed through their APIs, and it's associative with the Parasolid data. So it's a very powerful solution, and many of our customers are leveraging the combination of Hoops Exchange and Parasolid.
Great, thanks for that. There's a question here from Raihan. Can you shed light on what the docs are like, and is there any way we can access parts of it earlier? Evan?
So yeah, you mean before, if you want to access some docs before an evaluation, I mean, I would recommend you talk to us about an evaluation. We can get you going very quickly with an evaluation, have access to everything. So that's really the way to go. There are some documents we can send you prior to an evaluation, so just contact us for that, such as an overview of Parasolid document that's quite comprehensive. But yeah, an evaluation is very easy to get started. It's free. It's 90 days by default, and we can extend as needed, and you'll get access to the whole shebang.
Great.
I would also, sorry, I would also like to add on the documentation side that I really consider it quite awesome, because it's not just a list of functions and what each function does, what each option does. It also includes a lot of just conceptual descriptions of how different things work, not just in Parasolid, but in computational geometry in general. So there is a comprehensive description of how NURBS, surfaces, and curves work, and so on. And I believe that if you give someone who hasn't worked with geometry Parasolid's documentation before, they can figure it out just going by that. It has really a lot of information.
We'll take one more from John. John Callan supplied quite a few questions. John, I'm sorry, we just don't have time to do all of them, but we'll answer one more. In AEC, does instancing versus copying reside within the application built on Parasolid, or is it determined within Parasolid? Was that one for you, Kirilo?
Yeah, maybe Kirilo, can you take that?
Yeah, well, if you are talking about the AC use case that I described, it actually supports both the concept of copying and instancing, and Parasolid in itself supports the very familiar way how we are working with assemblies. So with the assembly, you have your parts, and parts may be instanced, but there is only one definition of this part. So you may have one part repeated 100 times, and all of those are instances that are pointing to the same definition. So that is supported, and also you could create a standalone body from an instance and edit it in its own way. So it really supports both instancing and copying, and you can leverage it to your needs as you see fit.
Great. So unfortunately, we can't answer all the questions. I do apologize, specifically John, who had a lot of questions. We will answer them subsequently, and AMC Bridge and Siemens will get back to you on any unanswered questions or even set up a call. Do firstly here are the contact details for both Evan and Kirilo. It's going to be in the documentation that's going to be sent to you, and it's obviously available online to download within this web interface, but we'll be sending that to you anyway. Of course, there's the event in Cambridge, which Siemens and AMC Bridge would be delighted if you attended. I think it'd be very useful if you're already keen on this technology or you're interested in getting further information. This is the place where you will get the best information available, because the right people are there and a lot of customers. So a lot of developers are there, very interesting views. I've attended the conference a few times myself. So I think it's been on 3 times. I've been twice before, I believe. And it is extremely interesting to see what types of applications are developed on it and how people go about leveraging the Parasolid libraries. I think it saves me to say that I want to thank you, the audience, for giving us your time. It's been, from our side, interesting to hear the questions you've got. We obviously are very keen to hear any more from you. Please fill out the questionnaire that's going to be provided to you, the feedback form, which is here, and obviously this will be available when you receive the PDF. So scan this and respond. All information is very useful. We do appreciate your time. It's very important that we acknowledge that, and also the time of our guests who are presenting here, Evan and Kirilo, and obviously all the people in the background who set up this particular webinar. Thank you for attending. I hope you've enjoyed it, and we appreciate your time.